Hello everyone, my name is Ratul Sharkar Shishir, and my student ID is 2248672 In this video, I will explain my final term OB assignment for the course Digital Logic and Circuit. The topic of my assignment is Digital Parking Control System. Mm, where we monitor available parking space using sensor counter, timer circuit, and finite state machine. Mm, now I will start explaining. First, I calculate the maximum parking capacity using my student ID. My ID is 2248672 So, according to the instruction B equal to 2, F equal to 7, H equal to 3. Total parking capacity is calculated as B plus F plus H 2 plus 7 plus 3 12 cars. So parking garage can hold a maximum of 12 cars. Next I selected the counter size. Since the maximum counter is 12 and 12 binary is 1100. We need a 4-bit counter because 3-bit are not needed to represent 12. Block diagram. Now I will explain block diagram show on this page. Entry sensor indicates when a car enters. Exit sensor indicates when car leaves. These sensors are connected to up down center. Entry counter counts up, exit counter counts down. The counter output in is sent to a comparator. The comparator checks whether the counter is equal to 12. The count 12 displays the full, and if count 12 display show space available. So block diagram show overall working principles. The parking control system. Flow diagram explanation. The flow diagram explain how the system works step by step. First, the system start and initialize the counter to 0. Then each continuously checks the entry and exit sensor. If a car enter the counter increments. If car exit the counter decrements. After updating the count, the system compares its the maximum value, which is 12. If count equal to 12, the system display full. Otherwise, display space available in blinking mode. This process continue in a loop. Now I will explain the counter design. Mm, The counter is built using flip-flops connect the sequential manner. Each flip-flop store 1 bit. Since when we need 4 bit, we use 4 flip-flops. The clock control when the counter updates the up-down control logic dictates whether the counter increases or decreases based on the sensor input. 7. The timer controls the blinking space available display. Mm, Variable মানে calculation using my id digit a equal to 2, b equal to 2, d equal to 8, e equal to 6, g equal to 2. So here is calculation. P equal to a plus b plus d plus e plus g into 2. P equal to 2 to 6 plus 2 into equal 40. Mm, duty circle duty circle is given day equal to p minus 100 minus p 100 minus 40 equal to 60%. Frequency is calculated f equal to a plus c plus 5 to 2 plus 4 plus 5 11 hertz. Timer calculation and time period t equal to 1 f to 90.9 ms on time 60%, so 54.5 ms of time, 36.4 ms. Component selection using standard 5 timer available formulas. I calculate rb uh, rb হচ্ছে 1.5 কিলো ওহম আর এ হচ্ছে 0.52 কিলো ওহম। Timer circuit diagram. This page show actual circuit diagram. The circuit use a triple bar timer in triple timer in stable mode. The resistors are A and RB and the capacitor C are placed according to the standard configuration. The circuit continuously generates a square wave. The square wave causes the space available sign to blink with the calculate on and off times. FSM design and FSM timing constant. Check the clock period is 1 ms. um, T TH 5.4 and TL equal to 36.4 ms. ডিজাইন হচ্ছে FSM design. For test for output A and for test for output B, state behavior state 0 equal to 0 to 3, A equal to 1, B equal to 0, state 4 to 7, B equal to 1, A equal to 0. Now code explanation. And 3-bit register store the current state on every clock pulse. The state increments based on the state value output A or B. Uh, Activate these create and control on and off pattern using digital logic. Mm, Limitation and future improvements. And this system has fixed capacity 12 cars. The 555 timer is analog, so it may have timing um, increases expanding the system requires hardware change. Future improvements modification use a higher at it higher use a higher bit counter such as 8-bit for larger parking areas. Replace the 555 timer with an FPGA to microcontroller based timer and memory and display drives for better scalability. Now conclusion. This concludes my video presentation on the digital parking control system. Thank you everyone.